Namaste, welcome to Arduino series YouTube lecture. In this video, you will learn how to control DC motor with Arduino UNO using L289N motor driver. After completing this lecture video, you will know how to control speed and direction of DC motor in Proteus simulation software. No, you can make also hardware using same circuit connections. When you learn these simulations, then you can easily make the hardware project. Before we entering into the coding and schematics part, first we will understand about the components and Arduino coding functions that will be used. Before we enter into the coding and schematics part, first we will understand about the components and the Arduino coding functions that we will use. First is Arduino UNO. It is 8-bit microcontroller. It is programmed by using Arduino IDE software and USB cable. Arduino sends and receives the signal through digital and analog pins. The Arduino sends the high or low signals and also PWM signals according to the code which is uploaded in Arduino UNO. And the next is L298N motor driver. The motor driver receives a small signal from Arduino and it amplifies that signals to required operating voltage of a DC motor. The current and voltage rating of motor driver you can find in data sheets. In this motor driver you can see total of 6 input jumper pins. In there, ENA and ENB is used to control the speed of DC motor 1 and 2. When we use constant speeds, then simply you can connect the this jumper to the 5 volt and the other is 2 pins, iron 1 and iron 2. It is used to control the directions of motor 1, and the last two pin is iron 3 and iron 4 is used to control the direction of motor 2. And we have last components is a DC motor. The DC motors have a two terminal. The motor rotates in one direction when we connect the positive and negative in these terminals. When we reverse the polarity of the terminal, the motor rotates in reverse direction. So that covers everything I want to say about the components. Now let's move on to the coding part, in which you will know the function and its working, which will use in programming. First is pin mode. It need two arguments. First is a pin number and second is input or output. The pin mode is used to define the mode of the pin. When we use the pin as an input, then we need to write here the input, and when we use this pin as the output, then we need to write here the output. And second is the digital write. It also have two arguments. First is pin numbers and second is the high or low. The digital write function is used to send the high or low signal through this pin. When we want to send the high signal, then we need to write here high, and otherwise we send the low signal, then we need to write here low. And the last one functions we will be used is analog write. The analog write is used to write the PWM signal through this pin, and it have also two arguments. First is pin number, and second is the value. The value is you can write here the value 0 to 255. Okay, so open the Proteus software and click on the new project. Here you can change the name of the project. So our project is the motor DC motor control, so you can write here any name, motor control, and you can choose the path. So I leave as it is, and then click on the next. So you can nothing change here, leave as it is, next, also leave as it is, next, and here also leave as it is, click on the next, and click on the finish. So our schematic capture windows is now opened. So first pick the required component. So click on the P and search Arduino UNO so you can here the results are appeared, Arduino UNO. So you can choose Arduino UNO TEP or Arduino UNO TEP. So okay, so you can choose, you can pick this Arduino UNO. So here Arduino UNO is appeared in our window, and then other device is the L298. Okay, L298. So here L298 double full bridge driver is appear, so you can pick it, and the last component is the DC motor. Okay, so you can search DC motor, so here DC motor active, animated. So okay, so you can pick the motor active simple DC motor model. Okay, so now you can place one by one to the schematic capture window. So you can place first Arduino L298. Okay, and the last one is DC motor. So you can also Okay, you can also place two DC motor. So first one, okay, so you can leave as it is. And so place them. Then you can go to the terminal modes, and here default, so you can connect this default pin to see our to look good. Then connect this default terminal pin to look our screen good, not a zigzag. Okay, so you can connect them, place and connect it. Okay, connect it, and the last enable be connect. Okay, so also you can connect the motor. You can connect directly, but what happen when you connect it directly, the, in the Windows there is many wire, so it not see clear. So you can connect it using the your default terminal pins. So you can write rename is terminal, so it is in one, and the next is into, and third is in 3, and fourth is in 4, and ENA, and ENB, and also you placed here rotate them 180 degree, rotate it to 180 degree. Okay, so this is out 1, out 2, also place two default terminals. So rotate it 180 degree, and the last one is rotate 180 degree and connect it here. Okay, and named it out 1, out 1, out 2, out 3, out 4. Okay, and also you can copy it and place here, and otherwise you can write here out 1, out 2, and for other motors, next motor 2, out 3, okay, sorry, out 3 and out 4. Okay, so the okay, connect here the VCC. Go to the generator mode, and here is DC. Okay, so you can connect here the DC voltage, and you can sort these two pins. So this is a 9 volt, 9 volt. Okay, and okay, so motor so you can increase the size. Okay. So okay, you can connect the ground here in the motor driver. Increase some size. Okay. Okay, in 1, in 2, in 3, in 4 and in. So you can connect this pin in Arduino. So in 1, in 2, in 3, in 4 you can connect the digital pin. So I connect this to 7 8 7 8 and 7 8 12 13. Okay, you can connect any pin. 7 8 9 10. Okay, I connect it in 7 8 9 10. So you can rotate it 180 degree and simply you can block copy. Okay, so 2 3 and 4, and for the E and A and E and B you can you must be connected it in the PWM pin. So this is E. Okay, so this is 9 8 9 10 11. Okay, so this is 11 okay, connect it 8 and 9 10 and okay, I made mistake here, so connect it in 11. You can also connect it 12, not a problem, and connect it to the 6 6, and the last one is in the okay 6 and it is in the 5. So okay, 0 1 2 3 4 5 6 7, 6 and 7. So 6 7 8 9 10. Okay, now write the E in 1. In 1, in 2, in 3, in 4, and E N A E N B. Okay, so our circuit connection is now completed. Now you can now let's move into the Arduino ID. Okay, so first define the pin. uh, so we connect the uh, pin in 8, 9, 10, 11, and the PWM pin in E6 and 5. So first define all the pins here. So define in 1 11, define into in 10, define in 3, in 9, define in 2. Okay, in 1, 2, 3, and in 4, in 4, in 8, and define ENA, define, okay, sorry, define ENA in 6, and last one is ENB, define ENB in 5. Okay, so our next we need to define the mode of the each pin. So first is in 1, so pin mode. This in 1 pin is we okay, so here nothing not any pin is used as a out input. So all the pins are using as a output pin. Nothing not any pin used as an input, because we haven't used any sensors. We only use the motor. So motor is controlled using the output. So here you can define the in all pin as a output. So in 1 output pin mode, into output pin mode, in 3 output pin mode, in 4 output pin mode ENA output, and the last pin is ENB, pin mode ENB output. Okay, so our setup part is also completed. Now we need to write the main program in void loop, which is run repeatedly. So here first we rotate the motor in the one directions, and then we rotate the motor in other directions. Okay, so digital write in 1 comma high digital right into comma low. Okay, it is for the first motor. And also for the speed you can write the analog write ENA comma, let's we rotate the motor in the 100 PWM. Okay, and for the second motor digital write in 3 comma high digital write in 4 comma low. And for the speed of the second motor we can write analog write ENB comma. Okay, so let's leave the 100. And after that, so both motor in the one directions. Let's put the delay here. Let's put the delay 1000, and I simply copied it from here. And okay, so let's put here. So after 100 milliseconds the motors rotate in the opposite direction. So simply you can write here low in the place of high. You can write low, and in the place of low you can simply write high. Okay, same here, can write the low and here high. So the motor rotates in the opposite in the reverse directions. So first our motor rotate in one directions with the speeds of the 100. You can put here any value from 0 to 255, 0 to 255, 0 to 255. Here also 0 to 255. Here also 0 to 255. Here also 0 to 255. 0 means motor stop, and 255 means motor rotate in maximum speed. Okay, so our code is now finished. So first motor rotates in one direction, both motor rotates in one direction. After 100 milliseconds the motor rotates in opposite directions, and it's repeated. Okay, so our coding part is finished. Now you can no so okay, save it, motor control, and verify it. So it is in compiling. Okay, I made mistake here. Okay, semicolon. So it is the okay, compiling is done. Now you can copy this the hex.hex file path, copy it, Ctrl C, and Now go to the Proteus software and paste this .hex path in your program file box and click OK. Now you can run the motor. Okay,